What factors have contributed to the sudden increase in adoption of LiDAR survey?
LiDAR coupled with this manual survey is the accurate one.
The accessible is not a matter now. From 2 kilometers away, you can access a place and you can do the survey with centimeter accuracy.
We can cover maximum with one throttle station team setup. We can do maximum 1 kilometer a day. Drone or this vehicle mounted, we can cover the entire 50 kilometer probably in 2 days. Our final outcome of this total exercise is to prepare a base plan. The base plan can be easily generated looking at an image.
So LiDAR survey can be conducted using various platforms, I understand, such as drones, helicopters, aircrafts, and satellites. How does the usability of the data differ across these platforms? Selva?
Mainly, the airborne survey, you can't only depend on the LiDAR, sir. LiDAR combined with the photogrammetry, LiDAR combined with a camera. So you have to generate a ortho image from the photogrammetry technique. LiDAR we are using for preparing the ground surface points. That means the ground points. So LiDAR will penetrate the trees, bushes area and hit the ground.
Okay.
Photogrammetry give you the topographic features. So you can map the 2D drawing from the photogrammetry data. You can make it as a 3D from the LiDAR data. So this is the airborne status. Other than the ground LiDAR, we have backpacks. You can go on very narrow lands. We can go on a slum area. Like that, you can collect all the data from the backpack LiDAR. Mobile LiDAR for the especially for the highway, railway, and you can fix it on a boat also. So the river banks, everything can be covered with the mobile LiDAR. Terrestrial LiDAR is for mainly for a interior area, the buildings, inner buildings like that, huge buildings. We can put the terrestrial LiDAR. We can collect the data. So compared to all this thing. Again, the accuracy is depending on our ground control points only, the traditional method, the conventional method.
So accuracy doesn't impact the mode what you're using for moving your LiDAR.
Yes, sir. For even it is a drone or airborne helicopter, everything, if you put number of ground control points, the accuracy will be the same. Compared to drone, the airborne LiDAR is from more height, it's hit the ground. So it is comparatively lesser accuracy than the drone LiDAR. Satellite LiDAR is again comparatively less accuracy than the helicopter LiDAR. Like that, because of the height, it's cross lot of things and hit the ground. So it may very less accuracy compared to the ground LiDAR actually.
Okay. Selva, obtaining accurate ground data beneath vegetation, trees, water bodies has always been a challenge, even with the traditional methods also. But with LiDAR, is it not being more difficult? And how does LiDAR technology overcome these obstacles?
For accuracy on a vegetation area, for LiDAR especially,
yes,
you will not get anything on your toleration survey. On your vegetation density area, you won't get anything. Yes. Compared to that, here you will get some data, not some data. It may be a real ground or some muddy places or something is there. No, LiDAR will show. It will not give the barrier. If a man goes and take a level, he knows whether it is a ground or not.
Correct.
From LiDAR, you get some object. It may be a ground or it may not be a ground. So what we do generally, when we collect the ground control point, we will randomly collect some real ground points from the conventional method also. The conventional method not only to the ground control points, some random points for validation of the LiDAR. So based on that, accuracy part, again I am saying, sir, if the ground control points available, if the ground control points within a accuracy limit, the same accuracy you will gain on the photogrammetry and the LiDAR. LiDAR is more accurate on the vegetation land. That's all.
Pattabhi, how do you ensure this data, whatever manipulation, not manipulation, interpolation, whatever they are doing to counter the problem?
Actually, Selva is right in saying that this vegetated area, total station, it will not give you anything unless we ask generally concessionaire or contractor to clear the area before we go with the total station. But here with the LiDAR, it gives millions of points, millions. Like it's not just vegetation is not covered completely. There may be some points, perhaps even if it is it requires only a small ray to penetrate. So even a small 1 mm of ground is visible, that also can be picked up. So when we have the larger data, then these guys with the help of, they can actually clearly identify in the 3D model. They can take out those vegetated areas like bushes, the trees that can be clearly eliminated. That they will mask it out. They will eliminate those areas, and they will give us only the data which is required to be representing as the actual natural ground there. So that is the kind of data we expect from these guys. They do that, and secondly, here the accuracy with which, as I already said, the point cloud gives is like it can give millions of points. Maybe at every centimeter it can shoot a point. But what we hardly need is a point at 5-meter interval. So the accuracy with which we are looking at is much more at a lower standard than what it actually gives. So it is so there is absolutely no problem at all. Even if they take out thousands of points also, we still have the required accuracy with us.
Okay. So that means if there is a gap between the vegetation or between the trees or between the plants or between the obstructions, so based on that, the interpolation goes on and you can deduce the proper ground levels, eliminating all that.
It is not even interpolation. We have the actual data. The interpolation is done in our software, in the design software. Like our even traditional methods also, we depend on interpolation only. We have points at every 5-meter interval. So we assume that the data within this 5 meter is uniform. That is the idea with which we go in normal traditional survey also. But here we have much more points, even every 1 meter also they can give.
Okay. That's right. So wherever the ground is changing abruptly, so you take this, pick these points at closer interval and then use it in your calculations or design.
Yes, yes.
What are some common anomalies and errors you have encountered while reviewing LiDAR survey data? See, the Selva and their team, they'll complete the survey and they process the data and they eliminate things which are not required, and they include all whatever intervals the data is required and give it to you. But what are the aspects or what are the common errors that you look into that? You can cite some examples also in your projects and explain to us.
Yeah, see, as Selva in his previous question, he has clearly mentioned the accuracy of the LiDAR survey will actually depend on the ground survey itself. If our ground survey is accurate, the LiDAR survey is also accurate. If there is an error in the ground survey, there is an error in the LiDAR survey also. The other aspect which doesn't depend on the ground survey is only the correlation part. If they don't take the point, the number, the level with which the count point is established, if they enter it as a wrong error, that is only the problem. That is a manual error only. It is not connected with LiDAR. It can happen even other traditional survey also. So that way, I don't see any problem. If the ground control points are accurate enough, it gives the same accuracy as that of normal total station survey. And the other point generally everybody talks about is the survey in waterlogged areas. It can't penetrate into the water and all. Even the total station also doesn't. We have to do sounding there also. Either you use bathymetric survey or echo sounder or with normal chain sounding. We go with a dipstick or with the sounding chain. We take the levels, we take the depths at every point across the river cross sections and all, and we take that as a depth only, and we correlate with our normal total station topo data. The same thing will happen here also. Because just because it doesn't enter into the water, we can't say that no, this is a problem. This is a problem everywhere. With our traditional throttle station also, we have the same problem.
Right.
So that additional data which needs to be supplemented is anyway required to be supplemented with LiDAR also.
Okay. While the ability to capture the millions of points, as Pattabhi and you guys are telling, no, per second is remarkable. Per second, it captures millions of points, you are saying. It's a remarkable advancement. Handling such vast amount of data presents its own challenges. So, itna data kaise handle kar rahe hain aap log? What are some of these challenges, particularly in terms of storage, processing, and utilization, and even transfer the data, the model, ground model, to the designer?
Storage is really a very costly affair, sir. Because
Okay.
one day we generate some 1 hour, the time-based thing. So 1 hour, if I run the LiDAR, I got 1 TB of data,
Oh
raw
my
data.
God.
So I have to keep the raw data, then I have to start the unzipping, then I have to geo-reference data. Till the end, I have to keep the raw data also. I have to keep the processed data also. Like that, there are some difficulties. Processing also, there are a lot of stages. First, we geo-reference data for the accuracy thing. Second, we take the data to different departments. One department, they will do line works, points, blocks, annotations, like that they will work on that. Another team will work on the ground classification. They have to extract the bare earth from the LiDAR data. So you will split the data to different departments. Everybody keeps the data for their work. Then I have to finalize the data for our clients. So for a single project, I have to keep different type of backups, different type of data with me. Now, generally, we will run 2-3 projects simultaneously. Means we will split it to different type of NAS storages, network storages, cloud storages based on the requirement. We keep the data like that. After once we finish everything, we keep the final data with us. We put all the raw data, the previous stage processing data, everything to a cold storage. We will not keep it on a server or something else. We put it on a cold storage. We keep it separately. If we require, we can retrieve the data from there. Otherwise, we will working on the final point cloud data and the final CAD files. This the thing. Okay, the final point cloud data also not a lighter thing. It also very huge. So immediately we will copy the data to a 4 TB hard disk, something like that, to shift to our client base. So the data storage is a difficult thing only.
Okay.
But nowadays the technologies are available. My server has a capacity of 240 TB.
Oh my
So
God.
I can the data to some different people. They will again store to my system, like that we are working. So.
Okay.
Storage is costly.
So with all the cloud and huge storage outsourcing agencies or outsourcing companies, no, you are able to manage this. This 240 TB size is something quite huge.
For my case, we have everything in-house. We outsource nothing from the for data processing or something.
Okay.
But even though I have to share the data with my client may go for a meeting or something else. If they don't have enough system capacity, they have to operate the data from the cloud only, because cloud can manage any number of data.
Right.
So cloud also we need, same as well as for our office work, we need a very huge storage system for that data.
Okay.
But
So it's huge, but it is manageable with all the new technology available.
Yeah. Now currently the storage capacities are available. There is no issues.
Right. So any
If I
challenge,
may add
Pattabhi, you have
Yeah.
once they do the processing and they transfer the data, getting the data transferred and for your work to be done, are there any challenges?
Yeah, initially we were very fascinated. We wanted the data at every, say, 2 meter, 3 meter, because it gives lots of data. But after seeing the actual
Difficulties.
reality, it comes in GBs. So in the traditional survey, when we have 5 meter interval, the cross sections, We hardly have maybe 30 points in a cross section, and that every 5 meter one cross section will be there. So we used to do a 25 kilometer or 30 kilometer file maximum size. We can even manage up to 25 to 30 kilometer in one single file. But after saying, initially we thought we will have lots of data, more accurate. We can find out even ditches and all, that we thought of having that. But we were stuck at even doing 5 kilometer, 10 kilometer. Then we again send back the data and we ask them to filter it out and give it only at 5 meter interval or 10 meter interval sometimes. So we don't need it. The supply is so huge, but we can't handle it. So what we will be needing is only a maximum 5 meter interval. That's it.
Yeah.
We sometimes, like very special works, like if you want to take a volume of a heap, for example, some aggregate pile up is there. There we can have, because that's a small area, limited to a small, this thing. We can have definitely a huge number of points. But that's actually, it comes in a definite shape. We don't need those many points. But if it is an irregular shape, like finding out the volume of a moss, a hill or something. So there we can have this as close as possible, because it is only limited to a small area. But in terms of kilometers of design, we can't handle such a huge data. We don't need it.
As you said, for 1 meter interval or 5 meter interval, the end outcome will not differ so much. So you've gone back and asked them to give at 5 minutes interval to manage your.
Yeah. Even with our workstations, we have i7 workstations with us. Even with our workstations, we will not be able to handle more than 25 kilometers.
Oh, okay.
So that will, even the file opening itself will take you a lot of time. And every time we move an IP, for example, when we are designing alignment, we move an IP, it takes a lot of time to regenerate the model.
Okay.
So we don't take such a large data into the design.
So basically, indirectly, it is slow down your design process by taking high resolution
it will
data.
slow down. We will only ask for that data where we have a specific requirement. Otherwise, we'll ask them to give this filtered out data. Like we need only 5 meter interval, and across the cross section also, we don't take every point. We take a 2 meter interval only. So every 5 meter longitudinally and cross section wise, we take 2 meter interval. That's the accuracy we generally require.
Okay. So I recollected one incident. In one project, what happened is there is a quarry mine, underground quarry, and the alignment was passing very close to that. So they didn't realize the right of way limit right of way limit passes through that quarry area. So the huge fill or realignment was required, but they didn't do that because in the plan and profile that's not visible. So when the work is implemented, people have gone to the site, then they have realized. Then it took a lot of time for realignment because they didn't realize the data was not there. So it took a lot of time and efforts in managing that during a construction stage. So I think with LiDAR, because they cover, as you said, Pattabhi said, the three-dimensional entire area, each and every point will be covered. So that would be useful to you to avoid this kind of mistakes, I suppose.
And an important thing is the extent it covers. It can give you a 100 meter width. In the traditional survey, we will confine ourselves to say right of way, 30 meter on either side maximum, or 25 meter on either side, whatever is the right of way available. And if you want more data, we have to go back to the site and pick it up. Correct. Here, we have the data with us. In case, if there is an alignment change, suddenly somebody wanted us to change the alignment for some reason at site, then we don't need to go back to the site. We can just pick up from the LiDAR because it has a larger coverage area.
Okay, good. Looking ahead, how do you foresee the role of artificial intelligence and data analytics in processing and making decisions based on large-scale LiDAR data sets? As Selva was saying, it takes 2 to 4 weeks to process the data, whatever is collected from site. Maybe inside LiDAR survey, it takes only 1 to 2 days, but processing it takes quite a long time. So whether artificial intelligence will help you in this, what would be the future of this LiDAR survey taking the help of artificial intelligence?
Actually, there is a lot of research is required here. Still, we are depending on the manual intervention only to specify the software, whether it is actually a ground or a bush. We still need to intervene manually. There are some software available which can pick it up and which can say that there is a bus. When we are using a mobile lidar, if there is a vehicle coming up in between, that can be completely taken out. Even looking at image or point cloud also, we can just take it out. Or even a tree can be eliminated. If it is the good thing about this is we can see it on the 3-dimensional. No, we can see it from the other side. It's not always from the top view plan. We can rotate it and see it. It actually looks like a tree. So those many points can be picked up and eliminated. This is actually a manual method only. This is not automatic. So there can be in future, what I'm expecting is a tree can be identified or even a vehicle can be identified. So these things can be automatic, but still a manual intervention would be required.
Okay. So there is huge scope of utilization of artificial intelligence to maximize the output and minimize your manual inputs, manual time required.
Right.
Okay, it's a very nice session. Lots of insights are shared by both of you. Thank you very much, Pattabhi and Selva. The elaborate discussion with you, the combo really worked well and made our audience clear about the LiDAR survey, its applications, benefits and limitations. Thank you once again, and I hope we will get you back to our show once again on another topic. Namaskar.
Thank you very much.
Thank you, audience, for listening our show. Stay connected to IndInfra Podcast with more and more stories that's going to come. So this will add value to your knowledge and help you going up in your career ladder. Thank you.